Hey everybody, this video today is about something called combining like terms. Might be given a more complicated example than you'll run into right away, but if you can do the hard ones, you can do the easy ones too. And again, I ran into this stuff right away in our curriculum. We are going to need to be able to combine some like terms, and I've got an example for you and a few definitions to kind of straighten things out here. So again, I'm working in these notes. And this will be the last of these notes in this section here. I came up with something here. Now, I wrote this stuff as simply as I can. This is called combining like terms. The very first thing you got to think about when someone says like term, you got to know what those are. What exactly are they talking about? And a very simple definition here is like terms have the same variables with exactly the same exponents. The numbers in front of them don't matter. Those are called coefficients. The variables and exponents are all that matters. I gave you an example and a non-example down here. These are like terms. Notice they have an x squared and a y. X squared, y. The numbers in front do not matter. These are unlike. We have x and y, but the exponents aren't the same. Okay? That's unlike. Now, had this one been missing one, they're still unlike. The variables have to be there with exactly the same exponents. All right, so the topic is called combining like terms. So I'm going to come down here and talk about, this is the formal reason, but when you put up a math textbook, this is how they explain the combine like terms. I know y'all have heard of the distributive property. We haven't formally introduced it yet, and we'll get to it. But I know you already have heard of it, so I felt comfortable putting that in here. It says, by the distributive property, we can combine like terms. For example, they say 3x plus 2x is actually 2 plus 3 parentheses x, because you could distribute this x to both of those things. That's a true statement. And we know that 2 plus 3 is 5, so we arrive at this here, 5x. Now, no one's going to expect you to do this right here like this. And if you were thinking about this, you said, well, you know, Mr. Ellis, it looked like to me, you could have just said 3 plus 2 is 5 and then write the x. That's exactly what you would do. So I came up with this definition here. There's probably a lot of math people that won't like this. First, note, you can't combine unlike terms. People have the tendency to want to try to do this. You can't. Don't even do it. It's simplified. For example, 3x squared plus 2x. These are not like terms because they don't have the same exponents. The expression is simplified. You can't do anything with that. Leave it alone. Okay? Here's my simple definition I said math people really won't like. To combine like terms, add the coefficients, that's the numbers in front, and copy the variables and exponents. It's that simple, guys. It's that simple. And one final note here, if you see a negative x, that's negative 1x. If you see the x by itself like this, and this applies to any variable, that is 1x. The coefficient is 1 if you don't see one. If you see a negative, it's negative 1, and so on and so forth. And I want to do this example right here with you. And I'm going to do it on this little scratch pad. Well, I call it a scratch pad, something like that, something I can write on. Because you got to stay organized. And let's take a look at it and see what we come up with. So this is that same expression written on the scratch pad. Let me move myself out of the way here. Maybe over here might be better. And the very first thing you need to do, now order, we're not going to get into which order this has to be written in right away. I'm going to keep my larger exponents out front, just out of convenience. And the very first thing I need to do is just pick a variable with an exponent and find out what's like with it. So for example, I'm going to start with that leading term there, x cubed. Okay? And I'm going to find things that are like with x cubed. There's one of them right there. I'm going to circle it. Staying organized in my head. What else is like with it? You've got to have the same variable and say exponent. This one right here is like with it. Right? So far, those are like. So I'm going to put those in a group and add them up. But I'm going to write it like this just for now. I'm going to say, well, this is negative 7x cubed plus negative x cubed, which is the same as that. There's one group. Now that's all those we see. We got all the like ones. And we're going to have another group right here. So let's go pick another color. We'll say we'll go with yellow. And we're going to find all the like. How about we'll go with y cubed? I like to put the larger exponents in front. So this guy, notice the negative sign comes with him. He's negative. The whole thing goes. Where's another one? There's another one right here. Right? And there's another one right here. All right, so we need to add those up. And that gives us negative 2y cubed plus 3y cubed plus 5y cubed. Okay, and finally, we're going to have the last thing here, which I know I don't really need to do a color with it because we kind of just see them now, but I'm going to stay consistent, is we've got, take the sign with it, the x and the negative 3x. And we'll put those in here. So we've done a really complicated example compared to what you're going to need. So if you can do these, I'm not going to give you many of these to do. Minus x minus 3x. All right, so we're going to come through here and combine these things. Negative 7 plus negative x, or negative 7 minus negative 1 is negative 8x cubed. All right, negative 2 plus 3 is 1, plus 5 is 6. So that's 6y cubed. And negative 1 plus negative 3 is negative 4. So I get negative 4x. And that's your answer. All right. I know that seemed kind of complicated, but if you keep it simple in your head, the only thing you're doing is staying organized, finding what's like. You didn't have to do all this grouping with parentheses here. You really don't. I mean, some people are going to be good at this where they can just say, hey, that's negative 7 minus 1, that's negative 8, right? Then you pick your y's. Negative 2 plus 3 is 1, plus 5 is 6. Go here. I mean, you don't have to do all that. Was just an illustration. And there may be other ways to stay organized with it vertically. Anyway, if you have trouble with this, let me know. And I guess for the note purposes, I'll put the answer. Uh-oh. I don't want to do that. For note purposes, I'll put the answer down here. Hopefully, I still have it on my clipboard. I do. Anyway, I hope this is helpful. Try those problems out. See how they do. See how you do. And let me know. But break into a Zoom meeting. Email me. Let me know if you're having a lot of trouble. And good luck. And I hope this was helpful.